This program will read a matrix, and it will perform mainly two operations on the matrix. First one, it will check whether the entered matrix is a sparse matrix or not. Then number two, if it is a sparse matrix, then it will represent the sparse matrix. It will represent the sparse matrix in a compact form. To represent the sparse matrix in the compact form, it will use another two-dimensional array or matrix. Another two-dimensional matrix will be used to represent the sparse matrix in a compact form. The new compact matrix will have what I mean to say, the number of rows in the compact matrix will be 3, and number of columns will be decided by number of non-zero elements. So that is why before we convert it to a compact matrix, what we need to do, first of all, we have to compute the total number of non-zero elements. And that can be done along with the operation. Then when we will be checking the matrix, whether it is a sparse matrix or not, we will also count the number of non-zero elements. If we do that, once we check the matrix, we will also have a value of non-zero element count. So that counter, the value stored in the counter, will be used as a number of columns in the compact matrix. To do this program, what I did here, first of all, I am declaring an array of integers. The name of the array is given as integer matrix, and also I am using two control variables I and j that will be used in for loops, and one more very special variable used here is count non-zero element, and this value will give you, at the end of the execution of the program, it will give you the value of non-zero elements in the sparse matrix. Taking these variables into account, let's see how this program works. At the end of this code, what we'll have, we will have some numbers here, say 0, 1, 0, 0, 0, 1, let us say 4, this is 0, 9, for example, 6, 0, 0, 0, 0, 5. Say. These are the elements entered. Now you have a matrix. And this matrix is named as integer matrix. So this loop is over. This block is completed. Now we will go to this block. Have you understood this part? Okay. Now again, it is the time to execute the second part, second loop. Not second loop, actually it is called second block. Now this is the time to execute the second block, this block. This first block is over. Now your control will go to the next block. What is next block here? Next block, this part, and it will come up to this one. And what I'm telling, following section will count the non-zero element. This is one. So here again, same thing will be repeated because it's a for loop. We have count. Now this we will make use of I is there. Remember, the variables will be there in the memory in the same location. Only content will be changed. Now here I am executing again the for statement. for statement, j will be initialized to 0. It will go to the inner for loop, initialize j with 0, and it will continue up to 0, 1, 2, 3 that way. But what it will do, it will check I equals to 0, j equals to 0. What is the value of 0, 0? In matrix 0, 0 is this one. In matrix 0, 0 is this one. What is this value? Greater than, not 0. It is not 0. If it is not 0, the count element, count was it was first initialized at the declaration itself, it was initialized to 0. Now it will be incremented by 1. Okay, then it will keep on going. It will go to next element, it will go to next element, because this is there are two for loops, nested for loops. And so first it will check this one. If it is greater than 0, then it will increment. This is not greater than 0, this is not greater than 0, this is not greater than 0, this is not greater than. But for 1, 2, 3, 4, these variables, count not non-zero element will not be incremented, so it is still 1. Now here, yes, when the value of I is equals to 1, that means outer for loop is executing for the second time, and inner for loop is executing with the value of j equals to 1. Means this is 1, 1. Okay, this is 1, 1. This is 1, 1. When it is 1, 1, the ij value is 4, which is greater than 0, not 0, not equals to 0. If not equals to 0, then count non-zero element will be incremented, so it will becomes 2. Then it will keep on going. So for this value, this is 9, this is 9. For this one also, it will be incremented by 1. That means it is 2 plus 1, which is equals to 3. Then it will go, this is 6. For this one also, it will be incremented. So 3 plus 1 is equals to 4. Then it will keep on going like this here. For this one value, it will be incremented by 1. 4 plus 1, which is equals to 5. Then the value at the time, at the moment when I is equals to 4 and j is equals to 4, it will come out of this loop. Now we are here. What is the value of count non-zero elements? Count non-zero elements is 5. 5 is less than 8. Why 8? Because 50% total number of elements are 4 by 4 matrix, which is equals to 16. 16 divided by 2, which is equals to 8. So the total number of elements, if it is less than 8 or less than or equal to 8, I am taking equal, but you cannot take equal. That's okay. So if it is less than 5, 5 is less than 8, that means it will execute this statement. The given matrix is a sparse matrix with number of elements given by count non-zero element, which is equals to 5. So this line will be displayed, and then it will come here. Then it will come here. What it is doing, it is simply printing this matrix. After that, we will go to the part where actually we are doing the conversion, where we will prepare the compact matrix. You see, I am creating one array. The name of the array is compact matrix. Compact matrix that will be created somewhere here. That will be created somewhere here. What I am telling, there will be 3 rows. There will be 3 rows. First row, second row, and third row. And how many columns? 5. Why 5? It is count non-zero element is equals to 5. That's why 1, 2, 3, 4, 5. Okay, and this is 0, this is 1, this is 2. This is 0, this is 1, this is 2, this is 3, this is 4. This is the matrix. The name of the matrix is compact matrix. Now what I am doing here, again I am considering I and j. I is 0, j is also 0. And if this is greater than 0, where greater than 0? Here it is greater than 0. When it is greater than 0, the value of I equals to 0, value of j is also equals to 0, value of k is also equals to 0. Right? All these things are 0. So what I will do, 0k, 0k means 0, 0. This element, this location. Okay. So at the beginning, when it executes I equals to 0, with I equals to 0, it will get inside here. So I equals to 0. then it will initialize j equals to 0, then k is already 0, previously k equals to 0. What I am doing, if now I am testing, if int matrix ij, int matrix ij means int matrix is this one, ij means 0 0, this element, if it is greater than 0, yes, this is greater than 0, so it will get inside this if construct. 0k means what? 0 compact matrix. I will come to this matrix, 0k means 0 0. Where is 0 0? 0 is this part, this point. What I will do, I will put the value of I. What is the value of I here? 0. I'll put 0. Then 1k means 1. What is 1? 1 means this one, right? 1, this one. 1 means row number 1 in the compact matrix, row 1, and k value 0, that is it becomes 1 0 this value. I will put the value of j is equals to also 0. And then in 2k is this one, k is 0, so it is 2 comma 0. In 2 comma 0, I will put the value of the int matrix, this one, I'll put 7 here, then I will continue. What I will do, I will continue with the j loop. Now j will be incremented by 1. Then we will check I equals to 0, j equals to 1, 0 1. 0 1 means this element I will check. If it is greater than 0, we will continue this loop for construct, otherwise I will go out. And every time we will increment the value of k. K will be 1 now. Then it will, what it will do, once we are inside this, we will increment. Now it will not go inside this for construct, it will go here, it will continue this, continue means for loop. This for loop will continue, it will test with j equals to 2, this one, then it will go on here. Here again, when the value of I equals to 1 and j equals to 1, this condition is satisfied, then what it will do, again this one will be repeated. What it will do, 0 comma k, what is the value of k now? It is, value of k is now 1, value of k is 1, this is incremented. 0 comma k will be equals to value of I. What is the value of I here? I is equals to 1, j is also 1, and the value is 4, like this. Then here it will go to this point, it will continue the loop, now the value of here at this point, this condition will be satisfied. At that point of time, value of k will be 2 and I will be 2 because we will be here at that time. I equals to 2, j equals to 1, so it will be 2 1 is 9. Similarly, it will go here, it will be 2 and j will be 2, that value will be 6, and again here it will be true, 3 will be 5. So this is the compact representation of the sparse matrix.